Hello and welcome to CET 4884 Security Methods and Practice. In previous sessions, we addressed the need for security in the organization. In addition, we addressed the ethical and legal issues that the organization and the security professionals should adhere to. The main goal is to reduce risk resulting of system vulnerabilities. A plan was developed to protect companies' assets, including database and information. Part of the planning was to use the proper technologies like hardware or software to secure the assets. This session will address some of the hardware and software technologies and tools to protect the company from external intruders. One of the most common tools that is used in the planning for security is firewalls. The planning of using firewalls technology will be discussed in various approaches. Also for the firewall will be addressed, and the implementation of firewalls as security measure will be explained. Technology can be used as a security tool on method to protect organizational assets. Actually, technical controls are very important in enforcing the company's policy for many IT functions that have no human control. With the increasing amount of information and data, there is an increase in the need to secure those assets. At the same time, the information must be available for users to review, read, and edit. So we have to balance the availability and security. So a technical control will be the solution to be used to balance the availability of the information and the security of this information from any intruders. To understand the technical controls, we need to look at the different tools that can be used to secure information. First, we can start by controlling who can access the information and how, and that could be done using what we called as access controls. So all this can be done using access controls. Access control determine whether and how to admit users into a trusted area of the organization. Access controls can be mandatory, can be non-discretionary, and discretionary. The mandatory access control, or the MAC, which is different than the Mac for Apple. This is more of just a control, and we call it MAC, mandatory access control. That is a system control policy restricting access to resource objects such as data files, devices, systems, etc., based on the level of authorization or clearance of the accessing entity, whether a person, process, or a device. In the discretionary access controls, a user has complete control over all programs and can determine the permission of other users on these programs. While in the non-discretionary access control, that's when the overall system administrator or a single management body within the organization tightly controls access to all resources for everybody on a network. To give the proper access, entities have to be identified. The identification process verifies the entity, the level of access, and the resources needed to be accessed. So when you look at the system, when you look at the security of the system and the employees, you need to verify or identify the levels of the employees, the devices, the processes within the system, and what will be the level of access for each one of them. The entity that seeks a resource is called supplicant. Each entity will be given a system identification or unique ID. It could be single and it could be composite. In addition, it could include numbers and or special characters. Some organizations use a random generator to generate random numbers for these entities. Once a supplicant requests an access, the supplicant's ID will be validated to make sure of their claim. This process is called authentication. The supplicant might know information such as a password or passphrase that only the user should know. So we use that password or that phrase to validate or verify that the applicant is who claims who he is or she is. Supplicant will be given access to other people's information because they can validate the account, which is not good. That's why it's important not to provide your password or passphrase to anyone and keep it in a safe place. Supplicant might have a smart card contains a computer chip that can verify and validate information. He might have also synchronous tokens that are time synchronized to an authentication server for the purpose of creating one-time password. The token and the server clocks must be synchronized to the same time base. And there is also a synchronous tokens generate a one-time password but do not use time synchronization between tokens and authentication server. And there are many ways now that you can verify with a third party, sending a text, sending you a code or certain numbers. There are many ways that can be done to make sure of the authentication of the supplicant. Matching the authentication entity to a list of information assets and providing them with the corresponding access level is called authorization. So we authenticated the user. Now we know who they are. Once they log in, they are provided with certain level of access, and this is what they are authorized to get to or to do, and that's why we call it authorization. So you have to know the difference between authentication and authorization. So basically you are authorizing the authenticated entity to access these directories with certain type of authority. Authorization can be handled in one of three ways: authorization for each authenticated user, authorization for members of a group, and authorization across multiple systems. So you can give it to a certain person, or you can create a group and give the whole group a certain level of authorization, or you can give multiple systems across multiple systems of the authorization. The authorized person will be accountable for the information he or she authorized to access. To identify the accountable person, we can verify system logs, which records specific information. To protect the system from untrusted entities, we can use a protection layer, or what is called a firewall. So a firewall basically prevents specific types of information from moving between the outside world, known as the untrusted network, and the inside world, known as the trusted network. The firewall may be a separate computer system, maybe a software service running on an existing router or a server, or a separate network containing a number of supporting devices. And as you can see, the firewall is a mix of hardware and software together to protect the network or the assets. Firewalls can be categorized by the processing mode, the development era, and the intended structure. Processing modes Categorized include, or categorization include, packet filtering, application gateways, circuit gateways, MAC layer firewalls, and hybrids. Packet filtering firewalls examine the header information of data packets that come into a network. The restrictions most commonly implemented are based on a combination of internet protocol, source and destination address, the IP address basically, direction, inbound or outbound, is it coming in or going out, transmission control protocols, which is the TCP, or user datagram protocol, which is the DUP, source and destination port requests. Some firewalls models examine one aspect of the packet header, the destination and source address. They enforce address restrictions rules designed to prohibit packets with certain addresses or partial addresses from passing through the device. They accomplish this through access control lists, or what we call them ACLs, which are created and modified by the firewall administrators. So basically it's updated on like quarterly or maybe even monthly basis. There are three subsets of packet filtering firewalls: the static filtering, the dynamic filtering, and the stateful inspection. The static filtering requires that the filtering rules governing how the firewall decides which packets are allowed and which are denied are developed and installed. The dynamic filtering allows the firewall to react to an emergent event and update or create rule to deal with the event. While static filtering firewalls allow an entire set of one type of packet to enter in response to authorized requests. The dynamic packet filtering firewalls allows only a particular packet with a particular source, destination, and port address to enter through the firewall. Stateful inspection firewalls, or stateful firewalls, keep track of each network connection between internal and external systems using a state table, which tracks the state and context of each packet in the conversation by recording which station sent what packet and when. Whereas simple packet filtering firewalls only allow or deny certain packets based on their address. A stateful firewall can block incoming packets that are not responses to internal requests. The primary disadvantage of this type of firewall is that additional processing required to manage and verify packets against the state table, which can leave the system vulnerable to denial of services or distribution denial of services attacks. This table shows a sample firewall rule and format. The application gateway, application level firewall, or application firewall is frequently installed on a dedicated computer separate from the filtering router, but it's commonly used in conjunction with a filtering router. The application firewall is also known as a proxy server, since it runs special software that acts as proxy for a server request. Since the proxy server is often placed in unsecured area of the network, or is placed in the DMZ, it rather than the web server is exposed to the higher levels of risk from the less trusted network. Now remember that the DMZ is open, so whatever server in that area can be seen by many users. Additional filtering routers can be implemented behind the proxy server, limiting access to the more secure internal system and thereby further protecting internal systems. The circuit gateway firewall operates at the transport area or layer. Connections are authorized based on addresses. Like filtering firewalls, circuit gateway firewalls don't usually look at data traffic flowing between one network and another, but they do prevent direct connections between one network and another. They accomplish this by creating tunnels connecting specific processes or systems on each side of the firewall, and then they allow only authorized traffic, such as a specific type of TCP connection for only authorized users in these tunnels. The MAC layer firewalls, while not as well known or widely referenced as the firewall approaches above, media access control layer firewalls are designed to operate at the media access control layer of the open systems interconnection. In that network model of communication, in that operating system interconnection network model of communication. This gives these firewalls the ability to consider the specific host computer's identity in its filtering decisions. Using this approach, the MAC address of specific host's computers are linked to ACL entries that identify the specific types of packets that can be sent to each host, and all other traffic is blocked or will be blocked. This figure shows firewalls types with the different OSI model layers. So far we addressed the packet filtering, the application gateways, the circuit gateways, the MAC layer firewalls, and the last one is the hybrid firewalls, which combine the elements of other types of firewalls. That is, the elements of packet filtering and proxy servers, or the packet filtering and circuit gateways. Alternately, a hybrid firewall system may actually consist of two separate firewall devices. Each is a separate firewall system, but they are connected so that they work together or in tandem to protect the assets or the network. First generation firewalls are static packets or static packet filtering firewalls, simple networking devices that filter packets according to their headers as the packet travel to and from the organization's networks. Second generation firewalls are application level firewalls or proxy servers that are dedicated systems, or we can consider them as dedicated systems that are separate from filtering routers and that provide intermediate services for requesters. The third generation firewalls are stateful inspection firewalls and monitor network connections between internal and external systems using state tables. The fourth generation firewalls are dynamic packet filtering firewalls and allow only a particular packet with particular source, destination, and port address to enter. The fifth generation firewalls are kernel proxy and are specialized from the works under the Windows NT or Executive, or the kernels for Windows, which is the new Windows that even we are using until this day. Firewalls can be also categorized by structure. Firewalls could be hardware or what's called appliances or software that can be configured on a device. Most firewalls are appliances, standalone, self-contained systems. There are commercial for large organization firewall systems, small office or home office firewall appliances referred to as SOHO, and residential grade firewall systems. This figure shows a sample of the SOHO firewalls devices. So which type of firewall should the residential user implement? Software or hardware? Where would you rather defend against a hacker? With the software option, the hacker is inside your computer, battling with a piece of software that may not have been correctly installed, configured, patched, upgraded, or designed. If the software happened to have a known vulnerability, the hacker could bypass it and then have unrestricted access to your system. With the hardware device, even if the hacker manages to crash the firewall system, your computer and information are still safely behind the now disabled connection, which is assigned to a non-routable IP address, making it virtually impossible to reach from the outside. Basically, if the firewall is down, there is no connection to get to the inside. Each of the firewall devices noted in the previous session can be configured in a number of network connection architectures. The firewall configuration that works best for a particular organization depends on three factors: the objectives of the network, the organization's ability to develop and implement the architectures, and the budget available for the function. Although literally hundreds of variations exist, there are four common architectural implementations of firewalls: the packet filtering routers, the screened host firewalls, the dual homed firewalls, and the screened subnet firewalls. Most organizations with an internet connection have a router as the interface to the internet at the perimeter. Many of these routers can be configured to reject packets that the organization does not allow into a network. The drawbacks to this type of system includes a lack of auditing and strong authentication, and the complexity of access controls list used to filter the packets can grow and degrade network performance. This figure shows an example of packet filtering routers. This architecture combines the packet filtering router with a separate dedicated firewall, such as an application proxy server, allowing the router to pre-screen packets to minimize the network traffic and load on the internal proxy. The application proxy examines an application layer protocol and performs the proxy services. This separate host is often referred to as the Bayesian or Bayesian host, or sacrificial host. We sacrifice with this host. It will be the trap, so nothing will come in. So it can be a rich target for external attacks and should be very thoroughly secured. But at the same time, if we lose it, then it will not affect the network. This figure shows an example of a screened host firewall. With this approach, the Bayesian host contains two network cards. one connected to the external network and one connected to the internal network, providing an additional layer of protection by requiring all traffic to go through the firewall to move between the internal and external networks. Implementation of this architecture often makes use of the NAT mapping, assigned IP addresses to special range of non-routable internal IP addresses, creating yet another barrier to intrusion from external attackers. This figure shows an example of a dual homed host firewall. The dominant architecture used today, that the screened subnet firewall, provides a DMZ which can be dedicated port on the firewall device, linking a single bastion or bastion host, or it can be connected to a screen or screen subnet. A common arrangement finds the subnet firewall consisting of two or more internal bastion hosts behind a packet filtering router, with each host protecting the trusted network. Connections from the outside or untrusted network are routed through an external filtering router. Connections from the outside or the untrusted network are routed into and then out of a routing firewall to the separate network segment known as the DMZ. Connections into the trusted internal network are allowed only from the DMZ bastion host server. The screened subnet is an entire network segment that performs two functions. It protects the DMZ systems and information from outside threats by providing a network of intermediate security. It protects the internal networks by limiting how external connections can gain access to internal systems. DMZs can also create extranets segments of the DMZ where additional authentication and authorization controls are put into place to provide services that are not available to the general public. The other thing that we can use is the socket secure, which is an internet protocol that routes network packets between a client and a server through a proxy server. The socket secure system requires support and management resources more than the traditional firewalls. So that will be all for this session. We're gonna stop here and we'll continue later. If you have any questions, please let me know. Thank you and have a great day.